Hey guys, welcome to my channel. So in this video we're going to look at how to find out or how to code a program to find out the GCD of any two numbers, right? So we're mostly going to focus on the Euclidean algorithm for this case, and there are multiple ways to do this, but we're going to look at the optimal way and the most used way throughout the industry. Now, before we do that, let's try to understand what GCD is briefly. I'm pretty sure most of you are aware of what it is, but still. So GCD basically of any two numbers, let's say GCD of A and B would be giving us as a function would be giving us a number. Let's call it anything like D, let's say. Oh, that's a horrible D. Like, let's say it's a D. Now, what's the significance of this D, right? So, it will be this. So, A will be equal to any number. Doesn't matter what number it is, but any number. Let's call it X. So, dx would give you A. So, that X multiplied with this number D that we get out of this function will be equals to A. And B, similarly, also again, multiplied by D. Any other number, let's say Y in this case, would be equal to B, like, right? So, and it doesn't have to be like different, X and Y doesn't have to be different, it can be the same, but then again, like, then they both become the same, like, number, right? In that case, you don't need to find the GCD. So that's the mathematical way of saying what GCD might be. So, and why do we try to find this? Well, GCD is useful in a lot of cases, cryptography, and if you're like trying to do competitive programming, you might need to find out the LCM and whatnot. So in that case, oh, by the way, so the LCM of A and B, so it's a formula that you might want to know and you might want to keep in your head. So LCM of any number A and B will be the multiplication of both of them, the product, upon the GCD of those two numbers, A and B, right? So if you find out the GCD of those two numbers, you can basically find out the LCM of them too. So which is pretty handy and comes handy when you're dealing with cryptography, as I said, and cryptic data and whatnot, and also and all other stuff. Now let's go to the coding part of things, right? So there are multiple ways to find out the GCD. Now when we were kids, we would do this like this, like let's say we have 15 and we have 5, so we'll write out the prime, like we'll decompose these numbers, I don't know, like disintegrate or something like that, and then we'll write down the factors of it. So in this case, it's 3 multiplied by 5. It's 1 multiplied by 5. Okay, there's 1 in here too, but that is not significant. But and then we like write down the common prime factors, which is 5 in this case, only 5. So yeah, this is the GCD, basically the greatest common dividend. So the greatest number that can divide both of them, right? So that's how we used to do it. And there are other ways to do it too, but in this this video we're going to learn about the Euclidean algorithm. The way it is done is basically we try to divide the bigger number with the smaller number until we reach like at a point that the bigger number can actually be fully divided by, you know, the smaller number, and then we just say that, okay, so this is the point, we're just going to return back the number that we just, you know, got after dividing, and that's the GCD, right? So let's try to understand it after writing this code, right? As I said, let's try to code the function. So it'll be static, it's going to return an int. The int is the D, you know, like the number D, which is the GCD basically. Let's call it GCD, let's keep it simple, and int A and B. It's going to take in 2 integers obviously, and now it's going to be a recursive function. So it's going to keep on doing the modulus, of the two numbers. So it's going to take in the two numbers and again and again and again, and it's going to return it after like we reach 0, right? The modulus of those two numbers reaches 0. Now, so let's write the recursive like the base case, which will be when a hits 0, we'll just return b. As I said, like when because you'll realize what we're doing right now. Let's code the second part of the things, then it'll be much more clear, right? Or else we're just if a is not equal to 0, we're just going to return the function itself with a being the modulus of b by a. I mean, I don't know how to call it, but like modulus b of a or something like that. And then b would be now a, right? So that has changed. So what we basically did in here, now it'll make sense. Now the base case will actually make sense. So let's say we have, let's say a equals 15. Let's keep b as the bigger number to keep things simple, right? So a equals 5 and b equals 15, right? That's an equal sign. So what happens first is the function goes here, and you know, a is definitely not 0, it's 5 right now. So it doesn't do anything. Now, so it's going to do this. So it's going to return the function itself. Now, b modulus a, this is going to be returned as a now, right? Which is what? Which is 0, right? Because 15 modulus 5 is going to be 0. So 0, and a will be returned as, b will be returned as the current a, which is 5, because it's just going through ones. And when it goes to here, it's now the a is 0 and b is 5, and now it hits this base case, right? Because you know it's a base case. So it says that okay, a is actually 0. Now I'm gonna return b, and b is in this case, remember that the previous a, which was 5, right? So yeah, it says that okay, now we've done everything. I'm just going to return 5 as the answer, and that's the GCD. And we realized and we saw that the GCD of 15 and 5 is actually 5, right? We saw that in doing our own method that we used to do since we were kids. So yeah, that's how this function works. Now, how it works? Basically, it's going on the principle of division, as I explained. It basically keeps on dividing those two numbers, but we're taking the modulus, but let's visualize it by the fact that you're dividing, and then we get to a point where we can actually divide the whole thing, the number properly with that smaller number, and then that's when we know that okay, so this is where this is where we stop and we have the GCD, because both of the numbers can now be divided. We get the modulus of both of the numbers 0, so we know that the number that we just divided with, the number that was just a, is now our answer. So yeah. And if you're getting confused by a and b, so basically this b is like the previous a, that's this a, right? So don't need to be confused. It's just that this thing is hitting 0, thus returning this thing, because this thing was the previous a, right? So it's very simple. Like, you guys can try to code this up yourself, and like take bigger numbers. Let's say okay, let's run this, right? So int a, let's say, is 55, and int b equals I don't know, 11, and let's store it somewhere. I don't know, let's just print it anyway. So GCD of a and b, I mean, I could have just written down the numbers, but anyway, it should be 11, right? So let's run it, and it gives you 11 as expected. Now in this case, remember that we did take b as the bigger number, because the bigger number modulus smaller number makes sense, right? So what about in this case? well, no need to worry about that because A might be bigger now. So if you do a modulus of a smaller number with a bigger number, it's just gonna like give you the smaller number back. So in the second case, the A is just gonna become the smaller number. I don't know if it makes sense, but let's take an example. So let's say A equals 55 and B equals 11. So we have the function, and in the second line it says return GCD of B modulus A and A, right? So B is 11, which is smaller, and A is like 55. So this will just be 11 because any bigger number that is in here will just like be this number, which is the smaller number, right? So that it's just gonna be the smaller number, and A is A itself, 55. And now when we come in here, we see that now we return this, and this is this, right? And now A becomes what? A becomes 11, and this A is actually B in here, so B becomes 55 in the second case, because like we're doing it recursively. And that makes sense because now B is the bigger number and A is the smaller number, so it just fixes it in one step. So we don't need to worry about that. So just a tiny detail you might be intrigued about and to know about. So I just cleared that doubt perhaps. But for the most of you guys are now probably well versed with the Euclidean algorithm, and you can actually implement it all by yourself, I hope. And yeah, that's it for this video. And if you guys enjoyed it, smash the like button and leave a comment, and that's it. Thank you.